Hi, everybody. Mr. Wyatt here again. Whew, what a week this has been with all the geometry, so many terms, so many new things to learn. Well, I have good news today for you. Today's lesson is going to be, I think it'll be pretty easy for you. Today's lesson isn't so bad at all. So it'll be a nice break, especially being Friday today. So, anyway, topic 7.5 um, section 4, classifying triangles. You already probably know a lot of these terms. So that's going to help a lot today instead of having more new terms to memorize. We can classify different types of triangles. All triangles have three sides and three angles. Actually, that's why we call them triangles, right? Tri means three angles. Um, but don't we usually think of triangles, and we always say they have three sides, so why don't we call them tri-sides? Maybe we could start a trend. Hey, did you see the picture of the tri-side? Well, maybe not. We'll stick with triangles. But anyway, if we want to classify different types of triangles based upon the lengths of their sides, if all three sides are different in length, and you see I have a 1 mark here, 2 marks here, 3 marks here, that's just indicating none of the sides happen to have the same measurement. If all three sides are different in lengths, that's known as a scalene triangle. Scalene triangles. All three sides are different lengths. Now, if two of the sides have the same measurement, see this side and this side both have 2 marks on them, showing that they are congruent, but we have another side that's a different length here. This is known as an isosceles triangle. It has exactly two equal side lengths. Notice the spelling here, Isosceles. I know that's weird, isosceles, why the extra C in there? Hey, it's a Greek thing, man. All right. And then thirdly, if all three sides are the same length, if all three sides are congruent, we call this equilateral. It's almost like the word equal, isn't it? It has the same root there. But you'll notice equilateral has an I here instead of an A. It's not equal like EQUA, it's EQUI. That's your prefix. Equilateral. Lateral means sides. Okay, lateral just means sides. So meaning they're all the same, lateral sides. Okay, all three sides are the same length, equilateral. So scalene, no equal sides. Isosceles, two equal sides. Equilateral, all three sides are congruent. We can also classify triangles by the angle measures. And we talked about acute, obtuse, and right angles. Well, we can also refer to triangles with these same terms. An acute triangle is one that has three angles that are all less than 90 degrees. This is less than 90 degrees. This is less than 90 degrees. This is less than 90 degrees. So it's an acute triangle. Right triangles, we all know them. We all love them. They have one 90-degree angle, one right angle. That makes it a right triangle. By the way, it's impossible for a triangle to have more than one right angle, because once you draw in two right angles, well, you're not going to be able to have a triangle anymore because these two sides are going to end up being parallel since they both are um, perpendicular to this side right here. Those will be parallel. So it's impossible to have a triangle with more than one right angle. Okay, so this is a right triangle. You see the right angle there. The two other angles are less than 90 degrees. They're acute angles, but it's a right triangle since there is a right angle. And an obtuse triangle has one obtuse angle. Look how large this angle is here. It almost looks like a coat hanger. If I were to hang a hook like, there you go, hang up your shirt now. Yeah, that's an obtuse triangle right there because it has an obtuse angle. All right, now the other key piece of information we need to discuss today, and you might even already know this too. The sum of the angle measures of all triangles is 180 degrees. Sum is what you get when you add, right? If you add up all the angle measures in a triangle, it always totals 180 degrees. This angle plus this angle plus this angle must equal 180 degrees. This angle, this angle, this angle together must total 180 degrees. That's true. No matter what type of triangle you have, it's always the case. So can I find a missing measurement if I'm given the other angles? If you look at this figure, if I want to find the measurement of angle X, can you think of a way I could do this? I know this angle here is 42 degrees. I also know this angle is 90 degrees. Well, if you take 42 plus 90 plus this angle here, it needs to have a sum of 180 degrees. So why don't I add together these two measurements that I already know, 90 and 42. I'll add those up. 90 plus 42. Let's see how many degrees we have so far. 0 and 2 is 2, 9 and 4 is 13. That's 132 degrees in these two angles. Now, if I need another angle to add to this to get my sum of 180, well, I could stay in the same fact family and just subtract 132 degrees from 180. And once I do that, I should get the measurement of angle X. So let's see what I get. 2 from 0, well, I'm going to have to regroup. Make this 8, 7. This becomes 10. 10 minus 2 is 8, 7 minus 3 is 4, and 1 minus 1 is 0. So I get 48 degrees. That's the measurement of angle X. And let's check it to make sure that works by adding these all together. 48 plus 42. I'm going to add those because 8 and 2 make a 10. You add those up, that's 90. If you add that to 90 here, that will total 180 degrees. So yes, angle X does need to be 48 degrees. Sometimes people will say, well, Mr. Wyatt, I did it another way. I took 180. I started at 180, and using a calculator, I went minus 42 equals, and then I went minus 90 equals, and I still got 48 degrees. Can I do that? Well, yes, you can do that too. It works very well. Okay, let's try another one here. How do I find the measurement of angle Y here? Well, I know the other two angles in this triangle. They are 84 degrees and 48 degrees. So what would angle Y have to equal? Well, let's figure out what 84 plus 48 is. I'll add them together. 4 and 8 is 12, carry the 1. 8, 9, 13. We have 132 degrees. Hey, we had 132 degrees in the last problem too. Maybe I should have chosen some numbers that were a little bit more different instead of having them come out the same. Oh, boring. Anyway, if I know these two angles are 132 degrees combined, and I know all three together have to total 180 degrees, then I have one more step. Subtract 132 from 180, and that'll give me the missing angle measurement. So again, 2 from 0 is problematic. So I'm going to make the 8 a 7. This becomes 10. 10 minus 2 is 8. 7 minus 3 is 4. 1 minus 1 is 0. So I get 48 degrees again. Angle Y is 48 degrees. Hey, just as a side note, you see how this triangle has two angles that are the same measurement? That actually means the sides across from them will have the same measurement. This is an isosceles triangle because it has two angles that are the same measurement. Just like if there were two sides that were the same measurement, it would be isosceles. It's also an acute triangle because all three angles are less than 90 degrees. This over here is a right triangle. See the 90-degree angle there. But you can find that missing angle measurement if you know the other two angles just by adding up the ones you know and then subtracting that from 180 degrees to find your missing angle measurement. Is that pretty easy? Can you handle that? And we can show our work here. It's important to show your work. All right, find the measure of one angle of an equilateral triangle. What if I called this angle X degrees? How would I find its measurement? Do I have enough information? Normally, we want to know what the other two angles are, and then we can work with that then to find that missing third angle. But I don't have any of the angles in this problem. So is there any way for me to know what the measurement is there of angle X? There is, and the secret here is it's an equilateral triangle, meaning that all the sides are the same length. And you know what? If all the sides are the same length, then all of its angles have the same measurement as well. Now there are three angles here, and they're all the same measurement. So how would I find the measurement of just one of those angles? Well, all three of them are the same. So if you take 3 times that measurement there, it has to equal 180 degrees. So it seems to me if I just divide by 3, I could solve this. And I find out X is 60 degrees. So I know this would be 60 degrees. This is also 60 degrees. This is also 60 degrees because 60 plus 60 plus 60, or 60 times 3, equals 180 degrees. So actually, even without being given any of the measurements of that angle, since it's an equilateral triangle, I was able to find the measurement of each of those angles by just dividing 180 equally between them, dividing by 3. Okay, that's it for today. I hope you found that easier. You just have to know how to classify triangles by the lengths of the sides, scalene, isosceles, equilateral, and by the angle measurements, acute, obtuse, and right. And you need to be able to find a missing angle measurement if you're given the other two angle measurements. Okay, that's it. Have a nice day.